Hello, yes, and welcome to our last quiz before our final quiz F.5, where it goes over Unit 5. Hopefully all of this stuff is still fresh in our head from the Unit 5 exam that we just finished last week. But again, the goal here is that you have already completed this quiz and then watch this video to check your work. So if you haven't done that, go ahead and get that done. This quiz aligns with problems 39 through 48, 39 to the end of the review. And if you've got it done, then let's just dive right in and get this thing started. So looking at number 1, we're going to solve for the variables. There are 4 variables here we're going to look at. X, Y, Z, and W. For these, let's just create these equations real quick. So I'm going to have 2 times negative 1 plus Y equals 10. 2 times 5 plus Z minus 4 equals 9. 2 times 4X plus 3 equals negative 13. And 2 times 3 plus 4W equals 8. And again, we got that just by the location of where they are in the matrix. Don't forget the 2 out front there. That's important. And then we can just solve these. So this is negative 2 plus Y equals 10. So that means Y equals 12. 10 plus Z minus 4 is 9, which means that Z 10 minus 4 is 6 equals 9. So subtract the 6, which means that Z equals 3. We would have 8x when we add this here is negative 13. Subtract the 3, so 8x would equal negative 16, which means that x equals negative 2. And W here, this is 6 plus 4W equals 8. Subtract the 6, 4W equals 2, which means that W equals 1/2. And, for these, I'd probably just keep them separate, show that what each variable equals, no coordinate pairs, nothing like that. But that's it for number 1 there. All right. Let's look at number 2. Solve the following system of equations. Okay. So this is a 3 by 4 matrix. So let's start by putting this into the augmented matrix. Be sure to show that works. So we'll have negative 4, negative 2, 5, 1, negative 6, 2, 5, negative 1, negative 6, 6, 3, and negative 3. Alright, so now let's RREF and see what we get. So in my calculator, on my calculator, with my calculator, I'm going to second matrix. I'm going to edit matrix A, which is a 3 by 4. I have negative 4, negative 2, 5, 1, negative 6, 2, 5, negative 1, negative 6, 6, 3, and negative 3. Okay, so I'm going to second matrix math up to RREF, enter second matrix A, close parentheses. Oh no, look at what we have. Well, let's math frac this, because we like fractions in our matrices. So 1, 0, negative 1, 0, 0, 1, negative 1/2, negative 1/2, 1, negative 1/2, negative 1/2, and then a bottom row of zeros, which of course means infinite solutions. Now remember, if we have infinite solutions, that doesn't mean we are done. We don't just write infinite solutions. We need to finish this off. So let's write these equations. So I would have x minus z equals 0 and y minus 1/2 z equals negative 1/2. And now I'm going to say let z equal a. So this becomes x minus a equals 0, which means that x equals a. Y minus 1/2 a equals negative 1/2. So I need to add 1/2, so y would equal positive 1/2 a minus 1/2. And of course z equals a. So from here I can write my coordinate pair x a y 1/2 a minus 1/2 and z a. And there we go for number 2. All right, so remember, if we have infinite solutions, we need to, still write it in terms of a. We let z equal a, and we can solve it from there. All right, solve the following. Oh, man. So this is, notice we do not have the same degrees, so we're going to have to solve this using substitution. That's okay. We can do that. Let's figure out what y equals here. So I'm going to subtract 3x from both sides. So that means that y, or negative y, will equal negative 3x plus 5, which means that y will equal 3x minus 5. Now from there, I can plug that into my top equation. So I'll say x squared plus, instead of y squared, I'm going to say 3x minus 5 squared equals 5. So we'll have x squared plus, oh boy, 9x squared. This will become minus 30x plus 25 equals 5. So I'm going to have 10x squared minus 30x plus 20, once I subtract that 5 over, equals 0. I can divide all of this by 10. Of course, technically I have to divide 0 by 10 too, and I get x squared minus 3x plus 2 equals 0. So when I solve this, I would get, well, I'm going to solve by factoring, so x minus 2, x minus 1, which means that x equals 2 or x equals 1. Now I'm not done. Remember, now that I know what x equals, I have to figure out what y equals. So I'm going to say that y equals 3 times 2 minus 5. So that would be 6 minus 5, which means y equals 1, which gives me the coordinate point 2, 1. And y equals 3 times 1 minus 5, which would be 3 minus 5, which would be negative 2. So that would be the coordinate point 1, negative 2. And there are my two solutions. Very nice. All right. Sam, Allison, and Chloe bought indoor houseplants for their beautiful homes. Sam bought 3 jade plants, 2 rubber fig trees for $44. Allison bought 1 jade, 1 rubber fig, and 1 aloe for $33. Chloe bought 2 rubber fig and 2 aloe for $50. How much does each plant cost? Okay, so let's create some variables here. We'll say J equals a jade plant, R equals a rubber fig tree, and we'll say A equals an aloe bush. So let's create these equations. So we'll start with Sam. Sam bought 3 jade and 2 rubber fig for $44. Allison bought 1 jade, 1 rubber fig, and 1 aloe for $33. And Chloe bought 2 rubber figs and 2 aloes for $50. Alright, so from here I need to create a matrix. So let's do that. So 3, 2, 0, and 44 for my first equation. 1, 1, 1, and 33. Now notice this one doesn't have a jade, but it has 2 of the others and 50. There we go. And now we can solve this by RREF. So let's type this into our calculator. So second matrix, let's edit this 3 by 4. So 3, 2, 0, and 44. And then 1, 1, 1, and 33. And 0, 2, 2, and 50. Okay, so second quit, second. No, that didn't work, sorry. So second matrix, go over to math, RREF, here we go. Second matrix A, close the parentheses. Beautiful. Alright, so be sure to write this matrix when you're doing this on your final. Show all your work. 1, 0, 0, 8, 0, 1, 0, 10, and 0, 0, 1, 15. So this first variable was J, so a jade plant is $8. That was supposed to be a $sign. I messed that one up. Rubber fig tree is $10. And then the aloe bush is $15. There we go. Not bad at all. Okay. Lastly, we're going to graph the inequalities. Be sure to shade appropriately. Okay, so I see right away x is greater than -5. I'm going to do that one first. Should have a dashed line. If I plug in 0, I get a true statement, so we'd be going that way of that one. 2x plus y, so I'm going to subtract 2x, so y is less than or equal to -2x plus 6. Up 6, 1, 2, 3, 4, 5, 6. 1, here we go. Down 2, right 1, of course. For this one, I will have a solid line since it is less than or equal to. And when I plug in 0, 0, 0 is less than or equal to 6, which is indeed true, so I get a true statement. So that'll look like that. And the last one, y is less than 1/3 x plus 1. And then I go up 1 and over 3, up 1 and over 3, up 1 and over 3, down 1 and left 3, down 1 and left 3, down 1 and left 3. I need a dashed line here. And when I plug in 0, I get 0 is less than 1, which is also true. So this one will shade this way, which means that my shaded region is this section right here. Beautiful. All right, and that's it for number 5, which means we have completed our final quiz for our final review, which also means we have completed our final video of the year. Hopefully you're feeling confident and ready to take on that JCCC final. It has been a pleasure doing all these videos with you, hoping you're staying happy and healthy and feeling good about where we are right now. So, this is Mr. Carter, and for the last time, this is Mr. Carter signing off. I will not see you next time, because there ain't a next time. Good luck on your final. I wish you all the best.